Hey folks, Matt Dunn here, lead penetration tester with Raxis, and today I'm going to take you through the basics of cross-site scripting, also known as XSS. I'll discuss and demonstrate each of the three main forms, which are reflected, stored, and DOM-based cross-site scripting. After that, we'll go through remediations for cross-site scripting vulnerabilities and how you can protect against cross-site scripting in your web applications. So let's get to it. Cross-site scripting is an injection-based attack, which allows an attacker to execute JavaScript in the victim's browser. This can cause cookie theft, credential theft, and all sorts of other payloads, which I'll go into more detail in a future video. Reflected cross-site scripting is when an application takes user-supplied data and includes it on a web page without sanitizing it first. A malicious user could input HTML or malicious JavaScript, as we'll see in later videos. We call this reflected because the user must have a way to send the request and have it immediately sent back with that data. We commonly see this in URL parameters, such as search terms, and other parameters as well. In our case, we'll be using this URL search parameter on a fake Raxis blog in order to demonstrate the approach. A regular user may search for something like Raxis, and the search result is reflected back on the screen seen here. However, if a user puts in JavaScript, the JavaScript is executed because the data is not sanitized. If we look at the top of the search bar, we'll see that the script content is in the URL parameter search. So a malicious user could send this in a phishing attack or other methods of delivery in order to have this code execute in a user's browser. Stored cross-site scripting is similar in that user-supplied data is included on the web page without being sanitized, but it is different in that that data is stored in the web application and served at a later time to users. It is not reflected back from a malicious request. In our example, we will be submitting stored cross-site scripting payloads through the comment section of this fake Raxis blog. And we scroll down, we see that there is one current comment on the blog, and that the blog allows us to insert our name as well as our comment. A normal comment maybe looks like this. And we'll scroll down, and we see that our comment is here. However, we can insert another one, but this time we will put our cross-site scripting payload. Now when the page reloads, this stored cross-site scripting payload executes, and this alert box pops up on the screen as the JavaScript is loaded on the page. Now if we see that this comment is not here because the script tag is invisible after it launches, the next time some other user, including ourselves, comes back to this page, it will execute again, which we will demonstrate by reloading the page. And once again, we see that this payload is executed. DOM-based cross-site scripting can be a form of either reflective or stored cross-site scripting. DOM-based cross-site scripting happens when user-supplied data ends up at a JavaScript sink and is not sanitized. A JavaScript sink is a function that can affect the document object model, also known as the DOM. Document.write is one of these functions. In this example, as you can see in the console, I have written out an h1 tag, hello world. If I enter that in, it overwrites the web page with the words hello world. Going back to our fake blog example, we can use the search function in the same way. This time, we use JavaScript for search by checking the checkbox. Once again, the document.write that we have in the page is writing this to the screen. This time, we'll enter in our payload, which is just going to be our usual alert-based proof of concept. We'll check the JavaScript search so that way it uses document.write to write it to the page, and we'll click search. As we can see, this got executed from being put into the document.write function. Now that we've talked about the three types of cross-site scripting, let's discuss remediation. Remediating cross-site scripting vulnerabilities is to take user-supplied data and properly sanitize it before it gets sent back to the web page. This includes all types of user-supplied data, including unlikely sources like Active Directory, which I'll talk about in a later video. Doing this sanitization by yourself can lead to errors, and that's why it's important to use well-known and security-tested libraries that have already gone through rigorous testing of their sanitization process.